welcome to my YouTube channel. Students, you are your greatest asset. Put your time, effort, hard work, sincerity, and dedication into acquiring knowledge, and in the process, you will definitely seek happiness, which is your greatest asset. So, happiness is a real sense of fulfillment that eventually comes from hard work. In this session, we will discuss the refraction of light through a glass slab, and by performing this activity, we will discuss the factors on which the lateral shift depends. Students, this is the diagram representing the deviation of light when the light is made to pass through a rectangular glass slab. This is the incident ray and this is the incident ray when produced, right? So when it is made to get incident on a glass slab in an oblique direction, then it bends. Now as we are aware, when the ray of light is traveling from rarer to denser medium, it tends to bend towards the normal. And over here, when the ray travels from denser to rarer, it will bend away from the normal. In case it's a rectangular glass slab, then the incident ray when produced and the emergent ray, these two are parallel to each other, right? And the perpendicular distance between the emergent ray and the incident ray when produced, that is what we call as lateral shift. In this activity, students, we are going to observe the refraction of light and study the lateral deviation of a beam of light when it is incident obliquely on a glass slab. Now, in order to perform this experiment, we need a glass slab. This is a rectangular parallel-sided glass slab, and we will also be requiring a drawing board, a sheet of white paper, pins, scale, protractor, pencil, and obviously drawing pins. Now initially we will fix a white paper on the drawing board and then we will place the glass slab on it. And with the help of a pencil, we will try to mark the boundary of this glass slab. Now students, with the help of a protractor and a scale, we will draw a normal on one of its face. Now as we are aware, normal is an imaginary line which is drawn perpendicular to the interface. So that's the normal. So wherever we are supposed to study refraction or for that matter reflection at a point, we need to draw a normal at that point. Now students, we need to draw the incident ray. For that, we again make use of a protractor and this is 10 degree, 20, 30 degree. So we will consider the angle of incidence to be 30 degree. Now here I need to mention that the angle of incidence is the angle which the incident ray makes with the normal. And students, don't forget to indicate this arrow. This indicates the direction of the incident ray. So the angle of incidence we have taken is 30 degree. Now students, we need to make use of the paper pins, and first we will fix pin P1 on this line and then we will fix the other pin, say P2, at around 10 centimeter away from the first pin. And it should be remembered that these two pins should be straight. Now we will look for the refracted image of the pins from the opposite face of the slab. Here you can see the image of those two pins. Now students, the most important part of the practical. Now what we need to do is, we need to place a third pin, say P3, in such a manner that all the three pins lie on the same straight line. Again I repeat students, while fixing the pin P3, care should be taken that the feet of the pins P3 and P1, P2 all should be in the same straight line. Now again, we will consider another fourth pin, that is P4, and it will again be placed in such a manner that the feet of the pins P3 and P4 should be brought in line with those of the images of the pins P1 and P2. Now students, it is to be done very patiently. As I've told you before, this is the most important aspect of the experiment. And all the 4 pins should be in the same straight line. They should be vertical. And on the incident ray, the minimum separation between the 2 pins should be 8 centimeter, 8 to 10 centimeter actually. Now you need to recheck it whether all the 4 pins are lying on the same straight line or not. I think now it's perfect. Okay, you can deviate or laterally shift your eyes and you can check, and there can be only one unique position where all the 4 pins will be in the same straight line. Students, you can observe from here that all the pins are well apart and they are vertical. Now remove the glass slab and then let's remove the pins one by one. And we will put small circles around their pricks. So this is the position for P3 and this was the position for P4. Now students, we will join the pricks of pins P3 and P4 with the help of this scale, and then it will actually represent the emergent ray. We can check, students, that the emergent ray and the incident ray when produced, they are parallel to each other. So what we have discussed is that, or rather what we have observed is that when the ray is incident obliquely on a glass slab, then it gets laterally deviated. This is obviously due to the refraction of light. Quantitatively or analytically, the perpendicular distance between the incident ray when produced and the emergent ray, that is what we call as the lateral shift. Now let's draw a normal over here. In that way, we can check the angle of emergence. Now using the protractor, if we measure the angle of emergence, it should be exactly equal to that of the angle of incidence. In our case, we have considered the angle of incidence to be 30 degree. So here, if we measure the angle of emergence, it also comes out to be exactly 30 degree. So the emergent ray and the incident ray when produced, they must be parallel to each other. So the angle of emergence, which is denoted by small letter e, it comes out to be 30 degree, which is exactly same as that of the angle of incidence. And here, students, d, small letter d, which is the perpendicular distance between the emergent ray and the incident ray when produced, that represents the lateral shift. This represents the incident ray, this one is the refracted ray, and this is the emergent ray. Now students, let us measure the angle of refraction. It is the angle which the refracted ray makes with the normal. So this angle would also be angle of refraction, as it is the pair of alternate interior angles. Now using D, we can measure the angle of refraction. And students, as you can notice, the angle of refraction, its value comes out to be 19 degree. So the value of R is equal to 19 degree. Now students, repeating the experiment for different angles of incidences, we get the ray diagram as it's shown on the figure. Now the point to be noted is that in each case, the angle of incidence, it is found to be exactly equal to that of the angle of emergence. So basically, this incident ray when produced and the emergent ray, they are parallel to each other. And obviously students, this is the angle of refraction, and this angle would be equal to this angle, pair of alternate interior angles, right? So this is the diagram for angle of incidence 30 degree. Here the angle of refraction comes out to be 19 degree and angle of emergence is again 30 degree. And the lateral shift, which is the perpendicular distance between the emergent ray and the incident ray when produced, it comes out to be 1.1 centimeter, right? Now for the same thickness, if the angle of incidence is increased, say from 30 degree to 40 degree, then the lateral shift is found to be 1.7 centimeter. So that's the observation. So here again, this angle must be equal to this angle. Pair of alternate interior angles. And you can easily check that angle of incidence is equal to the angle of emergence. Angle of emergence is the angle which the emergent ray makes with the normal. So students, this is a ray diagram for different angle of incidence and for a given thickness of the glass slab. And by using Snell's law, which is the ratio of sin I to sin R, which is equal to the refractive index, right? So sin I divided by sin R, that will give us the refractive index of this material of this glass slab. Now these are other two ray diagrams which are applicable for the same angle of incidence but different thickness of the slab. So what you need to do is that initially the slab is placed like this and we will follow the same procedure as was done earlier. Now keeping the angle of incidence constant, we will place the slab in this particular manner and check for the lateral shift in both the cases. So what we observe is, students, for the same angle of incidence, look here I is equal to 30 degree. Here also angle of incidence is 30 degree. But obviously the thickness of the slab over here is 5.1 centimeter and over here the thickness of the slab is 7.8 centimeter. So the lateral shift in case of more thickness of the slab is found to be much larger as compared to the previous case. So students, the lateral shift, it increases with the thickness of the slab provided the angle of incidence remains constant, right? So here again you can check angle of incidence, it should be exactly equal to the angle of emergence. That is, the incident ray when produced and the emergent ray, they must be perfectly parallel to each other. And obviously this is the angle of refraction. It will be equal to this angle being pair of alternate interior angles, right? Similarly, over here this will be the angle of refraction and it will be equal to this angle. Again, pair of alternate interior angles. This is our observation table. So students, here what we have done is thickness of this slab was kept constant and angle of incidence was varied, right? For 30 degree angle of incidence, we have obtained the lateral shift to be 1.1 centimeter. While for 40 degree angle of incidence, the lateral shift is found to be 1.7 centimeter. So with the increase in the angle of incidence, the lateral shift increases provided the thickness of the slab is constant. And in the second scenario, students, now what we have done is angle of incidence is kept constant and the thickness of the slab is varied. So here you can check with the increase in the thickness of the slab, the lateral shift increases provided the angle of incidence is constant. So students, these are the two results which we have obtained after conducting this particular activity, right? Again I repeat, for a given thickness, the lateral shift increases with the increase in the angle of incidence and for a given angle of incidence, the lateral shift increases with the thickness of the slab. And students, one more thing, actually the lateral shift, it also depends upon the refractive index of the material of the glass. The more the refractive index of the material of the glass, the greater is the lateral shift. So students, that's it for this particular session. And keep watching my videos for new experiments and new theoretical topics. Thank you.